Welcome back. This is video 2 for lesson 5.6, and we're just going to look at one example and we will be done for today. We're going to find zeros when the leading coefficient is not 1. Well, that's true. I think the big point of this example is that this one has x to the 4th. So what do we do when it's even bigger than x cubed? Well, you may have to do synthetic division more than once, and we're going to see how that works out. Okay, so looking at this, first thing you're probably going to determine is, can't factor this. So when we can't factor, we list our list of rational zeros. All right, so we're going to list the possible rational zeros of f, and there are a bunch of them. And the reason for that is your p is 12. And so all your values, or your constant term is 12, so your values of p are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Your q values are going to be factors of 10. So you've got plus or minus 1, which we divided by for these, plus or minus 2, which is where these came from, plus or minus 5, you can see those represented here, and plus or minus 10. And the thing you need to realize is this is the cleaned up list. Originally, when you do your list of p over q, you're going to have a ton of values listed. But we've practiced that already, and so here's our simplified list. Now this is huge, and so we could spend a long time before we find one that works. So if you're working where you can use the calculator, okay, like if this is on the calculator portion of the test, or when you're working through problems, if you have a huge list like this, one thing you can do is go to your scratch pad and go to the graph and enter your function in for f1 and look and see if you can find some reasonable values, okay? So we're going to choose reasonable values from the list above to check using the graph of the function, okay? And so for f, the following values are reasonable. Now, we're not saying that they are what the exact roots are or the exact zeros are. They may not be, but we're just trying to get a decent starting place. So if we look here, there's one between -1 and -2. Well, -3/2 is -1.5, so that's certainly reasonable. So we're going to try x equals -3/2. And then there's one between 0 and -1. Well, -1/2 is between 0 and -1, so we're going to try that. On the next one, let's see, we've got one between 0 and 1. We could try 1/2, but let's try 3/5. It looks like it might be a little bit further to the right than just 1/2, so we'll try that. If it doesn't work, maybe we can come back and consider 1/2 if we need to. All right, so let's look. Here's 1, here's 2. We've got something between 2 and 3. Let's see, 12/5, that's a little bit bigger than 2, that's 2.4, so that could work. Okay, so what we do is we use the calculator to kind of give us clues, and we come up with a possible value for each of those zeros that we can see. Now it may be, like say this one that we said, it could be 3/5. Well, maybe it is 3/5, or maybe it is a rational zero. 3/5 is rational. Maybe it's an irrational zero close to that value. So there's always that possibility too. So we're not saying these are the zeros, we're just saying those are reasonable ones to try with our synthetic division. If we don't limit it, we could spend, an hour or an hour and a half, or more doing synthetic division with all of these values, which is still doable. That's what people used to have to do, but this will work. All right. So we're going to check the values, this little list, okay, starting with -3/2, and we're going to look for a 0. Hopefully we'll find one. All right, so we try -3/2. So here's our coefficients, and so we're going to bring down in our constant. 12 is a constant. We bring down the 10. 10 times -3/2 gives us -30/2, which is -15. -11 plus -15 is -26. Times -3/2, let's see, -26 divided by 2 is -13. -3 times -13 is 39. -42 plus 39 is -3. -3 times 3/2 is going to give us positive 9/2. 7 plus 9/2, let's see, that's 14/2 plus 9/2 is 23/2. Times -3/2, 23 times -3 is -69. 2 times 2 is 4. 12 plus that value is not going to be 0. Okay. In fact, it's negative 21/4. But once you can determine it's not 0, you don't have to spend a whole lot of time worrying about exactly what that value is. All we care about is 0 or not 0. It's not 0, so that value was not negative 3/2. It's close to negative 3/2, but it's not equal to negative 3/2. Negative 3/2 is not a 0. So we move to the next one. We try negative 1/2. So we bring down the 10. 10 times negative 1/2 is negative 5. Negative 11 plus negative 5 is negative 16. Times negative 1/2 is positive 8. Negative 42 plus 8 is negative 34. Times negative 1/2 is positive 17. Plus 7 is 24. 24 times negative 1/2 is negative 12. 12 plus negative 12 is 0. Yay! We found one that works, and it's always a very happy thing to do. So let's consider what we've done so far. We are going to factor out the binomial using the result of synthetic division. Okay, so we have x minus negative 1/2, so x plus 1/2. And then we use those coefficients. Remember, we use those coefficients. We'll get to them in just a second. We'll use these coefficients here, okay, to create our quotient. All right, we started off with x to the 4th, so this 10 is a coefficient of x cubed. And we just move on down the line. So we get 10x cubed minus 16x squared minus 34x plus 24. We still can't factor that, okay? And we can't use quadratic formula yet because this isn't a quadratic. All right. Well, one thing, guys, when we factor, we should be able to have integer coefficients because that's how we started with, and constant values. And we've got 1/2 here. So if you look, all of these are even. And so here's what we're going to do. We're going to factor a 2 out of each of these, and then we're going to move it and factor over here, okay, or multiply by the x plus 1/2. So we're going to factor 2 out of the second factor. So that's going to give us 2 times 5x cubed minus 8x squared minus 17x plus 12 because you factored a 2 out of each of those terms. Now we're going to take this 2 and we're going to distribute it to the first factor. And so that's going to give us, if we multiply 2 times x, that gives us 2x. 1/2 times 2 gives us 1. And then we've got 5x cubed minus 8x squared minus 17x plus 12. The good thing for that, too, is this gets us smaller values here. So that's nice. All right, so now what we have to do is we have to work with this cubic factor. And so we're going to kind of start the process over again by doing the p over q's for the cubic because we really need to get one more factor out and then we'll be down to a quadratic. So we're going to repeat the steps above for g of x equals 5x cubed minus 8x squared minus 17x plus 12. And any 0 of g will also be a factor, or 0 of f. Any factor of g will also be a factor of f. The possible rational zeros of g are, okay, it's a little bit smaller list because we have 12 here and we have 5 here. So the p's are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. But the q's are just plus or minus 1, plus or minus 5. So if you look, here's where we've divided by plus or minus 1, and here's where we've divided by plus or minus 5. Still a pretty big list. Okay, so we're going to look at the graph of g so we can pick a reasonable starting value. So here is g, which in your calculator will still be f1 of x. You just put it in there, and you look, okay? And we've got several values we could pick. I'm going to go with this one right here. I still, 3/5, that was on the other one. It's on this one. I think that might be a good value. So I'm going to start with that one. So I use my coefficients and constant from g. I've got 5, negative 8, negative 17, 12. I'm going to use 3/5. So I bring down the 5. 5 times 3/5 is 3. Negative 8 plus 3 is negative 5. Times 3/5 is negative 3. Negative 17 plus negative 3 is negative 20. So that gives me, when I multiply by 3/5, negative 60 over 5, which is negative 12. 12 plus negative 12 is 0. So 3/5 works for us. So the graph showed that 3/5 may be a 0, and synthetic division showed that it is a 0. And so g of x equals x minus 3/5 times 5x squared minus 5x minus 20. So we're going to factor out a 5. And then we're going to multiply that 5 times the first factor. So 5 times x is 5x. 5 times 3/5 is 3. So we've got 5x minus 3 times x squared minus x minus 4. Now this is just g of x. It follows that f of x was that original factor, the 2x plus 1, times g of x. So it is equal to 2x plus 1 times 5x minus 3 times x squared minus x minus 4. Okay, now we want to find the remaining zeros of f by solving x squared minus x minus 4. This is coming from the zero product property, that we can get the zeros by setting each of these factors equal to 0. Okay, now we know that this one is going to generate x equals negative 1/2. We know that this one is going to generate x equals 3/5. The question is, what does this one generate? Now we can try to factor that. Factoring that would be great. It's just that that's prime. So we're going to have to use quadratic formula. So x is going to equal negative b, so negative 1 plus or minus, that minus is kind of getting lost there, square root of b squared, so negative 1 squared, minus 4ac, so minus 4 times 1 for a and negative 4 for c, all over 2 times 1. We're going to simplify that. Let's see, negative 1 is 1. Here we have 1 minus negative 16, so 1 plus 16 is 17 over 2. And so we have two irrational zeros. They're real, and we can see them on the graph, but they are irrational. Okay, so if we had done synthetic division all day long, we would not have found these two. Okay, we have to use this method. So the real zeros of f are negative 1/2, 3/5, and x equals 1 minus square root of 17 over 2, and x equals 1 plus square root of 17 over 2. And you have to write, you can write it as two different solutions, or you can write the plus or minus. That's fine too. Okay, guys, that's it. You are ready to do your practice problems. Make sure you do those problems to try on your own before you come to class, so that you get full credit for your notes, and we will go over them when class gets started, and then we will get you started on your rounds. I'll see you soon. Have a good day.